way on the synthesis of material, okay, is it whether is it nano ke tak nano, dia ada dua, sama ada kita goes for the bottom up approach and the top down approach ataupun bottom up approach, top down approach or bottom up approach. So things that we are going to discuss in details lah. Alright, so you got the overall idea there, okay? That although this material is considered as a nanoparticle, okay, nano, always remember that is 1 to 100 nanometer, 100 1000, okay? So their range too is a bit limited, but there's always a way to design and prepare their functionalities, okay? And these functionalities going to have a specific what we call as application, yeah. So meaning that although the size is very small and fine, okay, there are certain functionalities that we want from this material so that we can functionalize it or fabricate it into certain what we call as properties, yeah. So the material is already small, but there's always ways in how to improve their properties. This is important when we are going to tailor the properties involved in the size, the shape, the composition, as well as the constituent. Okay. Of course, bila kita cakap tentang nanomaterial, we are going to look at the size and shape. Okay. That's we have learned previously. The size and shape ada properties yang akan affect dia. But we are also going to know that based on this way in designing the nanomaterial, we are going to look at the structures and the composition. Kita boleh jadikan dia not only a single particles, tapi kita boleh jadikan dia embed dengan nanoparticles lain. So still is a nano structure. Kita boleh juga tell it the structures. You are going to see that hari tu you nampak MCM 41 dekat dalam soalan kan, tiba ada lubang-lubang tu tapi ada bentuk hexagonals tu kan. Okay. And the question asks you whether this material is 1D or 2D, 3D. This is actually a 3D in overall. Okay, walaupun dia ada shape porous tu. So this is the things that is very unique in the nanomaterial, yeah. And because of the common way in the synthesis method, there is always two types, whether it is a top-down or a bottom-up approach. So walaupun property dia unique and small, tapi in any approach, okay, you can always have the top-down approach, tengok daripada atas ke bawah, ataupun bottom-up approach. Okay, so we are going to see the difference. And this is the first aspect that you have to consider in fabricating a nanomaterial. Satu, macam mana method kita nak buat tu. Kita nak ada benda yang besar, bulk, kita buat dia daripada top down, okay, ataupun kita nak design dia daripada molecules, okay, apa yang kita nak tambah dia lagi, nak fabricate dia. So this is bottom up. So you have to consider method 1 or method 2. And another thing that you have to consider when we are looking at the material, the nanomaterial, is the growth kinetics, okay, the pathway on how we are going to form the not only the particles, but in the end to avoid any certain agglomeration or impurities. Yeah, that's why we are going to monitor how the clusters, okay, benda yang kecil-kecil ni akan follow a certain what we call as growth profile. Okay, so dia ada plot dia yang akan ni tengok sebelum dia start agglomeration. Okay, we are going to avoid the what we call as agglomeration based on Oswald ripening. Kita tak nak sampai dia tak stabilized. So because we know that this material, the nanomaterial here, Due to the size and shape, the energy here is not really, the surface energy is not really stable. Okay, so kita kena avoid any agglomeration that going to disturb or in the end dia bagi impurities lah dekat sampel tu. Okay, this is in terms of the what we call as how we look at the approach, ya. Okay, sama ada top down method ni, okay, benda yang bulk, then dah besar tu kan, benda yang besar, kemudian kita slicekan dia ke, kita pecahkan dia ke, kita katuk dia ke kan, meaning that we enforce any certain forces, okay, and to change the bulk structures into a powders, okay. So lepas dia jadi powder ni, kita jadikan dia particle, kecil daripada particle is clusters and atom. This is how we look at the top down approach. But in terms of the bottom up approach, okay, this is usually where we look at the reaction. Okay, kita campurkan your solution A, campur solution B, ada atoms A tambah atom B, and this is also considered as an atom by atom or molecule by molecule. We look at the build up of a material. Please highlight the word build up of the material. Macam mana awak daripada dulu sekecil-kecilnya sampailah menjadi sebesar-besar. Sekarang dah besar, dah tak boleh nak kecil lagi. So that is how we look at the bottom up approach. So usually in terms of what we call as a top down technique here, it's involve a solid state. Okay. Kalau awak ada starting precursor, dia tak cakap kan, you are going to classify it whether the material here is going to be top down ke bottom up. Tengok starting material dia ni apa. Katalah lepas tu dia kata this is aluminium oxide, bauxite, Al2O3 is a bauxite. It's confirm is this is lepas tu dia cakap this is solid. So this is confirm as what we call as top down approach. But in a bottom up technique, okay, bottom up technique, usually you are going to involve a liquid or a gaseous stream. Okay, so this somehow indicate whether you are actually tailoring or fabricating a material based on an atom by atom approach or the by bulk approach. Okay, so sama ada you start dengan yang besar ataupun yang kecil. So that is the idea on how we look at the different approach. In the end, the things that you have to consider is that you need to control it in the nanoparticle region. Okay, so dia kalau awak terlebih bagi force, tengok dia akan jadi clusters atom, benda tu cair ke benda. Kalau awak terlebih tak control dia punya energy, in the end dia jadi agglomeration. So this is the crucial point on how we look at the energies that is going to be validized ataupun used in terms of the particles assembly. Okay, this is in terms of the common technique or method as an example ya. Okay, untuk cara awak top down approach daripada bulk pergi ke particles, usually use an excessive energy. Macam kita bagi energy yang berlebihan sebab benda tu besar kan. So macam mana benda nak besar ni, kita nak karate dia ke, nak gigit dia ke, nak kecilkan dia kan. So the most common one is usually thermal laser ablation. Okay, ni pakai energy laser lah, pakai thermodynamic approach, sama ada you introduce a laser ataupun thermal. Okay, this is the most common. Ataupun you use a mechanical, usually involving a ball milling. So ni dua yang famous lah. Or explosion process. Ni jarang lah dilakukan explosion process ni. Macam kau duduk dekat wari pula kan, nak main letup kan. So ni mungkin boleh diaplikasikan time awak buat meriam ke meriam raya nanti, boleh nak buat explosion process. But the most common one is whether you look at the external energy by thermal, laser, ataupun mechanical.